the scooter battery. What is the scooter battery? Well, is this battery pack here that is 36 volts and it comes off of a scooter, one of these guys. If you have been paying attention for the past couple of years, there are several companies that have been dropping hundreds of thousands of these in cities across the US and across the world, actually. But for one reason or another, eventually these end up in scrap yards. In this case, this company here sold the entire division of scooters to another company. And as a result of that, the new company doesn't want these on the street because they have the wrong logo. And so as a result of that, then there are just tons of this stuff that's available to anyone that wants to buy it. The average person doesn't know what to do with this stuff, right? This is a 10-pound paperweight. But to us, well, we know batteries, and so we can figure out how to use them, right? That's a good thing because this is probably a $200-300 battery pack that now we can get for about $50. So today I'm gonna show you the work that's been going in the background to try to figure out how to use these, because this is all proprietary hardware that has software in there. And so as a result of that, these batteries are kind of dead. They don't have power. They have the connector here, but if you connect something in there, they're just nothing. And so it takes a little bit of work to wake them up and to figure out how to use them, right? And so that's what we're gonna do today. All right, so first step, we gotta wake these guys up. Both of these are dormant, right? I have plugged in a meter here and another one here, and it doesn't show any power. How do you wake them up? That's easy. All you have to do is apply power to the charging port or to the discharging port. But they kind of react different. Let me show you here. I'm just gonna use a 2 amp, 42 volt, 2 amp charger. These are 42 volts batteries, and it does it at 2 amps. And it's got a little light here, right? So let's try this one first. So when this light turns red, it takes a little while. Then hopefully this will, okay, here we go. Just turn red, which means now it's charging. And now this battery is awake. It's at 33 volts, 33.6 volts, which is pretty low. So now you should be able to disconnect that. It doesn't stay on. Sometimes it stays on. Let's try it again. I think what happens is that it's too low. Once you can get the voltage up higher, then this will stay on. But this is the quickest way to wake them up. Let's try another way. Now, the other way is to go through the discharging port, right? Let's try that. So here we go. It's charging 34.81. But it's the same thing. These batteries are too dead. Once the voltage goes higher, then it will stay on. Now, what are the differences here? Well, I haven't seen too many differences, but through this port, through the charging port, you could only charge it at max speed of 5 amps. If you put 6 amps in here, then the BMS will turn itself off and it'll stop charging. Through this port, you can do up to 25 amps. All right, here now is a battery that I fully charged, or at least 90%. When you connect the meter on this one, it comes on, which means it's awake. The problem is, here, let me show you what happens. I'm gonna put a load on this one, right? I'm gonna try to charge this one, which is at a lower state of charge, from this one. There you go, I'm gonna connect it. And look at that, you see that? It's charging. See that? It's charging. But here's what happens. After 5 seconds, or about 6 seconds, I think, it quits. Here's what will happen. In about a minute, right? Exactly a minute after it came off, it will turn right back on. And then it'll stay on for 6 seconds, and then it'll come back off again. And it will do this at least 20 times, maybe indefinitely. I don't know. But at one point it will stop because these were dead when we got them. But maybe it stops once it gets like to the batteries are really low. But I stopped counting around 20 cycles. There we go. Turn right back on. Right, and in 6 seconds, boom, it turns right back off. Another minute, it'll turn right back on. It'll turn. So that is the problem with these batteries, that they need a signal on this pin right here, the blue pin. They need a signal to stay on. And so now, to be able to provide the signal that it needs, let's go to the desk. Now, a few days ago, I made a video asking you guys if anyone out there knew how to wake these batteries up, right? And a lot of you guys commented and sent me messages, right? But the very first person to actually send me a video, this was Brad Cagle. Brad Cagle sent me a video where he showed me his battery working.
All right, Jehu. I got this thing to work. I just went to bed last night, but yeah, I broke out one of the Arduinos. This is a 5-volt one my Arduino is on, and it should be sending pulses, that byte string to the battery pack every 5 seconds.
Okay, so he basically got his working with his e-bike, right? And what he did is also, he told me exactly what he did. He got an Arduino Nano, and then he programmed it with the byte that everyone was sharing, saying that that's what it was. Here I send them this picture showing that the blue wire was the receiver pin. So then that's the one that needed to hook up to the Arduino, right? And then something very important, he's the only person or one of 2 people that sent me an actual code here, right? The little sketch that, which is a little part of code that you are supposed to load up into the Arduino. So there we go. I got myself an Arduino. Let me show you how to load up that little sketch into it. It's pretty simple, but nonetheless, there's a lot of people like me that don't know much about this stuff, and I'm gonna show you exactly how I did it. First things first, you have to copy this code that he sent me here. And by the way, I posted this code up on Jehu's DIY Powerwalls group in Facebook, right? So if you need to get it, I posted in there. There's a post, and you can go get it. So here we go. After that, what you do is you load up the Arduino app. You have to go and download it, and there's other stuff, right? I tried this code in 2 different Arduinos. This is the one that he used first. I didn't have this at first. I only had an Uno. And for some reason, I couldn't get this code to work on the Uno. I don't know if it's just this particular one or if that code needs to be just modified slightly to work with the Uno. But I couldn't get it to work, but I did get it to work with the Nano. So here's what you do. You connect the Nano with the little USB cable, and then you connect that into your computer here. Here we go. And now it's got power. So here's what you do. Here's something that you will do. This thing already has a very simple piece of sketch or a piece of code in here that tells this pin, that port, to blink. This is the very basic blinking LED, right? And so that's preloaded in here. So what you can do is, once you have it connected in here, in order to make sure that you are connected to this and you are communicating with it, I am going to modify that blink code, and I'm gonna visually see that light change, right? And so that's just to make sure that I am actually communicating. So you go to this sketch thing here, you go to basics, and then there's a blink, and here's the code. It's very simple, right? And then what you can go and do here at the very bottom says delayed 1000 and then delay 1000. So that's how long this little light's supposed to be on. It's 1 second and then 1 second off. So if you change that, you just delete 1 0, right? Oh, here, So if you delete 10, now it's going to state, now it's gonna change the way that this light lights up. Right now it's 1 second on, 1 second off, 1 second on, 1 second. So then what you do is now you upload that, right? And then all these little lights flash in here, and there we go. See, now it stays off for a whole second, but then it stays on for only 1/10 or 1/100th of a second, whatever. It's like, yeah, 100 milliseconds to 1000 milliseconds, right? So there you go. Now we know that we are communicating with it. And so now what you can do is now you can delete all this stuff, right? Boom. So here I just pasted that code that I was sent, right? All the way from the very word that says void setup, right? And now what I'm going to do is I'm gonna load this one into the Arduino. Here we go. Come on, whatever. Don't save it, just upload it. Okay, so it did it, right? So here we go. Now that little light is not blinking, but what it is blinking every 5 seconds, the TX, which is the transmitter pin. Now that's blinking every 5 seconds, which means it's sending a signal. And the signal that it's sending is this right here, right? If you're watching this and if you know how to do this, you know, just bear with us. This is for us beginners that don't know much about coding and people that haven't done it. But once you do that, all you have to do is now connect the TX pin to that blue pin on the battery, and then get the ground to the ground of the battery, right? The ground pin to the, and then you just gotta provide power via the USB. So let's go check the batteries now, see if we can wake them up. All right, so here we go. Now I have made this little wire, and I have put these little pins on the Arduino there. The ground pin goes to the ground on the battery here, and then the blue one goes to the transmitter, TX, right? These are a couple capacitors, these are a couple resistors to lower down the 5 volts to 3.3 volts that it requires here. Now, I did this because Brad did that and he specified that on his little video. I also tried it without these resistors, and it also works. Now, I don't know, long term maybe it'll be a thing. It's only a 1.5 volts, but I don't know, this at this levels, maybe this electronics are super sensitive and it'll eventually burn it out. There's also another Arduino board, the Mini Pro, which is also 3.3 volts instead of 5 volts like this one. And so maybe that is a thing that we'll do in the future. But for right now, we're using this one because that code works on that one and we'll figure it out. So another thing to figure out, of course, is how to power it. This right here, the positive, we need to figure out how to get it from 42 volts when it's fully charged down to 3.3 volts or 5 volts, right? It's just to power this Arduino here. I ordered some small DC to DC little board. It's gonna take some time to get here. So for now, what we're gonna do is, luckily, this little meter here has a function that says USB charge, and it'll take the voltage from the battery and it'll spit it out through this USB port, right? And that's a USB charge function. So all I'm going to do is gonna connect my USB cable right here and then connect it to the Arduino, and then just click on the start USB charge. And just like that, that made it power up. And so now this Arduino now is spitting out those commands, right? It's those little things that it's doing. So now let's test this. Now this battery should stay on because it's getting the signal that it wants every 5 seconds, right? And so now we should be able to now charge our secondary battery. There we go. It's charging it, right? And here we go for more than 5 seconds, and it hasn't turned off. right? And now that should stay on indefinitely, because now it's getting the signal that it wants. So just like that, it's that easy. As long as that thing is powered, and as long as that's spitting out that code, those signals, and then this battery is receiving it, it'll stay on. And now you can charge through this port, or you can charge through this port, right? At this point, I don't know why we would want to slow charge on this port. I would say just charge through the same one, right? Because you can go in and out faster, because it's got all the MOSFETs there. So we could essentially just cut this wire and just, pretend that it wasn't there. Or you can use it. It's up to you guys, but you don't have to. You could literally go in and out through that same port. Now that we have this running, it's putting 9 amps, right? And of course I did these tests, and right as soon as you go above 25 amps through this, then it shuts down. The BMS protects itself. As soon as you try to charge faster than 5 amps here, this BMS also turns itself off. If the battery gets too hot, this will turn itself off. If the battery's hot, it won't charge, but you can leave the charger connected there, and after the battery cools off, then it'll start charging automatically. And so this BMS that's built in here, it's pretty good. It's pretty safe, especially if you leave them like that. Now, what can you do? Can you run multiple of these units with a single Arduino? Well, I think so. But, of course, the only way to find out is to try it. So let's go try that right now. All right, so here we go. Now we have a similar setup than we have last time, but slightly different, right? We just have more. So here we go. Same Arduino, right? Now this time without the resistors, they're just going straight, so it's spitting out 5 volts into the 3 volt systems here. Now I'm thinking that maybe because it's gotta go and split, right? So here's the signal. It goes to this one, to that one, and then it goes over here and to that one. It's just running parallel, right? Daisy chaining. So I'm thinking that maybe because it has to feed all of these 10 battery packs, the 5 volts is gonna be fine. I don't know if that's the case, but we will, I guess time will tell, right? So here we go. Now we're going to plug in this bank of inverters. This is 4,000 watts. And here's our little meter that tells us the voltage of each of the whole pack. It's at 40 volts right now. I didn't charge it all 100% all the way up, but it doesn't matter. So let's see how well it handles inrush. These inverters all have a bank of capacitors, and so when you connect them to the battery for the first time, it has to charge them, and you will see a sizable spark. It's not great because it doesn't. It just eats up your connectors. But there's ways to pre-charge these with like a resistor. Yeah, there's different ways, right? But we don't have any right now. Let's see how well it handles. I'm thinking that each one of these can do 25 amps of inrush, and so there's 10 of them. So you should be able to do a 250 amps of inrush, which is kind of scary to be able to do that on a connector like this, but I've done it before. Here's the spark to prove it. Hopefully, it's not too bad, because then it just destroys the connectors, and it could get a bit dangerous because of the flash, right, arcing and stuff. But let's see. I feel brave tonight. Let's do this thing. There we go. Okay, so yes, there we go. There we go. What's going on there? Oh, 23 volts? Oh, it's not. They're turning on and off. They're all turning on and off. It didn't do it. Wow, look at that. It didn't handle the inrush very well. Damn, okay. That sucks. So now we gotta wait and see if these batteries will start coming back on, right? A minute. It'll take usually about a minute for the first one that turned itself off to turn back on. And then hopefully that's gonna turn on this guy, that's gonna turn this guy on, and then it's gonna daisy chain the whole thing, right? Let's see if it happens. If not, then we're gonna have to wake these batteries up individually by putting a charge on the charging ports here. So now it's been more than a minute and these have not turned themselves on. So I guess we're gonna have to go manually turn them on. That kind of sucks. Okay, and we're gonna do that again with our little charger, right? So we'll just plug it in here. Right, there we go. Come on. Once this turns, there we go. So it's charging. But you know what? This did not. Oh, there we go. There it is. Now that turned on, this turned on. Right? Did all of them turn on? I don't know. Huh. You know what? I'm only going to turn one on. Let's try something else. All right, so I have set this power supply here to 42 volts. I am going to plug it in and let it slowly charge those capacitors. And then once these are charged, then I'll connect the batteries, right? And then hopefully that's gonna work. So here we go. There we go, there we go. Well, that says 42 volts. That should be charged now, 42.2. Okay, so now we should have those capacitors charged. There shouldn't be any spark here now. Let's plug it in. Wow. Let's see if we can turn all of these other batteries. As far as I know, only one of them is on, right? Okay, so now what I'm going to do is connect one of these and see if we see a load, and this single battery should be able to support that load. So it's showing 1 amp right now, and then we'll go and see which ones of these are on. So there we go, 6, 7, 22, 23. So it's doing 24 amps. So the way we're going to find out where that power is coming from is by measuring each individual battery here. So there we go. There's 3.6 amps coming from that one battery pack. Let's pick the other one here. 3.7 or 3.5 amps from the other one. So it seems like more batteries are woken at this point now. There we go, 3.8 is coming from that battery. Here we go, where's that one in there? 3.9 from that battery. What? 1.6 from this battery. Huh, I wonder why this one is 1.7 from this one right here. Yeah, 1.7. I wonder why that is. And here we go. There's 5 amps coming from this side of the board, which means that these are also 1.3, 1.2, 1.3 on this last one, and 1.1. All right. So it seems like the farther we are, then the least amount that they're. So this might not be the greatest setup that I have here, but now let's connect a bigger load here. Okay, I just connected the second inverter here, and is coming up now. Oh, look at that, 50 amps. That brought it up to 50 amps. Let's connect the third one in here. Yeah, these are 10. Should be able to support up to 200 amps. The batteries, the wiring and stuff here, maybe not so much. Here we go. I connected the third one. Here we go, 80 amps. 83 amps coming off of that. Let's see what these guys are doing. Yeah, so that's just what's happening. Let's connect the last one in here. There we go, 115 amps. There we go. We're doing 4,300 watts off of these 10 packs right here. All right, so after 20 minutes, you know, they're running fine. The extension cords are warm. The DC low voltage wires, those are hot. Look at that, like 50 degrees right there. But those batteries are staying pretty even. Pretty even. The inverters too. I mean, they're it's not that much. We're running them at 4,200 watts, right? That's not much. That's less than 1C on that. That's about 4,500 or 4.5 kilowatt hours worth of battery. So this, yeah, it's 1C. It'll last about an hour like this. So we've removed 1/5 of the power, the energy right now. Yeah, these batteries are awesome. So there you go. These are probably now going to be the easiest way and one of the most affordable ways to put a large battery system together, right? You literally grab these and throw them up in the wall. Just screw them. They have screw holes right here already, right? But the possibilities are kind of endless. I mean, you can use these as e-bike batteries because that's what they are. Use them as scooter batteries because that's what they are. Powerwalls, right? But here's what I'm thinking. I want to say 6 of these in our little box here that we have. Man, that's 3 kilowatt hours right there. 36 volts. Yes, you know, that's gonna be pretty cool. We're gonna probably offer those, start putting them in there, and offer just another variant of that. Yes, and the cool thing is that there's plenty of these. If you have in mind a big project, we have plenty of them, and we have another 2 truckloads of those coming. So yes, it's pretty exciting times for building DIY Powerwalls or DIY battery systems. I hope this video helped you out. I hope you can get what we did here. If not, I think if you're not into, you know, coding this thing, if you feel that this is not for you or whatever, I think we're gonna offer these already preloaded with the little wire, with the software, with the code on there, and then you can just, you know, connect them to your batteries and then use them the way it is, just to make it easier for everyone to use these batteries. All right, thank you for joining me. If you're building a DIY system, make sure you share it with the world, share it with us. It helps us to stay motivated and helps us to stay inspired by all of your projects, right? And so go to the Facebook group, Jayu's DIY Powerwalls on Facebook, and then share it there. All right, thank you for joining me. We'll see you on the next video. Bye.